Next one, no, wave theory. That only we are going to study as nature of electromagnetic radiation.
Sir,
Tell me, Nana.
sir, you didn't discuss Bohr atomic theory.
After this, we will discuss. No, once we will discuss about the these points. No, then we are going to find it out.
Okay, sir.
Uh, how what is the basics we are going to discuss? Okay, on which basis it was given.
Okay, sir.
Okay.
Okay, sir.
Generally, this wave theory was proposed by who proposed? Do you have any idea?
Sir,
Tell me, Anna.
sir, you said you will again say drawbacks of Rutherford's model.
Should I say repeat?
Sir, you did not explain what is a spectra of atom.
Spectrum of atom we will discuss now. In this coming topics we will discuss.
Okay.
ఇది టెలివిజన్ చాక్లెట్ తీసుకోండి.
Okay. This was proposed by. Okay. This was proposed by Maxwell. Okay. Okay. James Clerk Maxwell. It was proposed this, right? So
Sir,
actually, what they are saying that
sir, only J.J. Thomson and Rutherford gave the atomic models.
X only these two only given, and after that we have Sommerfeld's atomic model also. Okay. But
Okay.
now we are using all combined combination. We are using.
అది చాక్లెట్ తాగలేదు.
See, next one. The points he has given certain points under this theory. What they had given is the energy emitted from any source, like bulb or heated rod. Okay. Example, what we can say, he is talking about uh, heated rod or filament from the bulb. Okay. So the energy which is coming from any source you can take. For example, even if you are taking in normal tubelet also, you can compare. So the energy coming from any source, the energy emitted from any source, emitted continuously in the form of radiations. Okay, the energy coming from any source. That means what he is trying to say is, if you are taking energy, no, the energy will come from any source in the form of radiations. Okay, comes in the form of radiations, and the energy uh, associated with the radiation, the energy associated is called radiant energy. radiant to energy. That means what we can say simply, if you are taking from any source, no, you can take any source of light or anything. So it will come, it will reach, okay, in the form of radiations. And the energy with the radiation, we are saying that, okay, uh, radiant energy we can say. And next point is, these radiations, okay, possess, okay, these radiations consists of oscillating electric field and magnetic field. These two fields are perpendicular to each other and perpendicular to propagation of light. Propagation of direction of light. Propagation, simply you can say propagation of the radiation.
One second, can
For
you
Sir,
go
once
back
can you
and
go
show
to
the
the
previous
previous
slide?
slide? Sir, sir, you wrote perpendicular spelling wrong.
acha,
So propagation of energy.
one second, one second. Okay. Uh, propagation of the radiation. So I will tell you. For example, let me take, okay, this is source. Let me assume like this. So this is the propagation of the radiation. Propagation means direction of the radiation. Okay. So now what the radiations are there, no? So this will have two types of fields we are going to have. That is what we can say electric field and magnetic field it is going to be there. So let me take. So let me take the electric field is coming like this in the form of wave. Let me assume like this. Okay, this is what electric field if I'm taking. Now let me take propagation is x direction, no? Then electric field will be in y direction and perpendicular to this. So that means in the z direction we are going to have magnetic field direction like this. Okay, this is what we can say magnetic field.
Sir, once can you explain once again?
One second, one second. I haven't explained anything, Nana. Okay, so what I'm trying to say is, see here. For example, this is the source. Let me take which I'm indicating now. This one, and this direction is there, no? This one which I indicated with red color. This is like a direction of the radiation. Let me assume. So when the radiations, I told you, no, whenever according to this theory, whenever the radiations are coming, it will come continuously. It will come. Okay, and these radiations when they are moving, no, so they are going to have two types of fields they are going to have, that is electric field as well as a magnetic field. Okay, and this electric field and magnetic field, how it will be there, these two will be perpendicular to each other as well as perpendicular to the propagation of the wave. So to understand this, let me assume the direction of wave is okay in x direction. Okay, so that means in y direction we are going to have the electron magnetic field, it will be there. Okay, in z direction it can have electric field. Let me ask if I want to take now. This is the wave, right? Let me take likewise. These two are perpendicular, right? Yes or no? This is direction, this is the wave I'm writing.
Yes, sir.
Now what will happen? So towards this point, from this point towards yourself or towards myself. Okay, that means perpendicular to like this. Okay, so that they are going to come. That means what we want to what he want to say is whenever the radiations are coming, no, so they will create electric field and magnetic field, and both are in a oscillating direction only, oscillating manner only, and both we are going to get in a okay, which form we are going to get perpendicular to each other we are going to have. Okay, this is the point we can say.
Sir,
Next point we can say.
Sir, can you show the previous slide?
1 second. These radiations means whatever the radiations we are getting, no, so that's the reason simply we are saying that as the radiations are having electric as well as magnetic behavior, these radiations are called electromagnetic radiations, we can say. Okay, these radiations possess wave characters these radiations possess wave character and travel with the velocity of light. What is velocity of light?
3 into 10 power 8 meter per second, sir.
Very good. 3 into 10 to the power of 8 meters per second. Okay. Mm. This is what we can say about the uh, velocity. That means what these radiations, no, simply how light will fast travel in the same way it is going to travel. And next one, as these waves are these radiations possess electric and magnetic behavior.
well, in the third point is it wave character, sir?
Yes, yes, CHRACTER character. So electric and magnetic behavior called. So because of this uh, electric and magnetic character, these radiations are called okay electromagnetic radiations, we can say. Electromagnetic radiations, we can say this. Okay, na? Next, what we can say? Mm, these radiations doesn't require. Hold on 1 second.
It must be it చేయాలి ఇంకా.
Sir,
Tell me, Anna. These radiation doesn't require.
Sir, these radiations travel with velocity of light.
Yes, yes.
Okay.
These radiation doesn't require any material medium for propagation. Okay, that means it doesn't require any help or any medium also for the propagation. Just that means they can travel in vacuum also. That he want to say, right? That means simply the point we can observe from here. So in this theory, so any radiations, whether it can be light or heat or anything or electric also, they will come continuous manner only. They will come. Okay, they will come in continuously. It will come, and when they are coming, no, so they are going to have wave character as well. They are going to have electric and magnetic behavior. Fields are going to produce. So because of these fields only, those radiations only are called electromagnetic radiations. We are going to say. So now onwards, we are going to use each and every term as electromagnetic radiations. Okay, electromagnetic radiations we are going to right, and these radiations, no, they will have wave character, and simply they don't require any material for the propagation of the medium. Okay. Mm. Now
sir, 1
from
minute,
this
sir.
one, generally
Sir, 1
what
minute,
happened?
sir. I'm back. Sir,
Sir,
uh,
Previous slide.
So what is meant by propagation?
Propagation means direction.
sir,
Tell me.
sir, can't these radiations travel through solids and all?
It doesn't require, it can travel, no.
Yes, sir.
So they can travel from both, sir.
uh,
Vacuum and
Light, it can enter into anything, no.
Sir,
uh, Tell me, Anna.
sir, light is a type of radiation.
Obviously.
That means any type of radiation travels in electromagnetic waves, sir.
So all is going to produce electric field and magnetic field. That all we can say electromagnetic radiation only.
Okay, sir.
Sir,
Uh,
what is wave character?
Wave character means simply what are the waves are there, no? Like wave characteristics, like normal sound wave if you are taking. So what are the wave? How it will come in the form of waves, no? And they will have wavelength that I am going to discuss now. Okay, let me write that. Then you will get wave
Sir,
characteristics means simply wave behavior, no? Simply you can tell.
sir,
Tell me, Nana.
sir, thus the electromagnetic radiation will be slower in liquids,
Light can flow any direction, no? Even it will enter into liquid also, no?
but the speed will decrease, no, sir.
What?
The speed will decrease, no, sir.
Obviously, speed in vacuum it will have more speed, because if any material is coming, no, I'm not saying that no speed will, obviously it will decreases, because if I'm taking, no, if you are taking light from any sunlight, no, that sunlight completely will not go into deep of the sea, no.
No, sir.
That's the reason. Same way, light also same way only.
Okay,
Sir,
sir.
once can you go to the previous slide?
Done.
Okay, sir.
Mm.
sir, in 5th point, the last word is what, sir?
Propagation means direction.
Done, sir.
Okay. Mm. Next, see. Wave characteristics means simply how we can say wave. How wave we can say that. This is in this way we are going to have wave, right? Okay, it will have in this one, and in this one, wave characteristics means we are not discussing now. This is what we can say. This is crest, right?
Correct, sir.
And this is throw.
Correct. True.
Okay, throw. And now, first one, what we can say, what are the wave characteristics we can write? First one, wavelength is the wavelength.
So crest is directly proportional to trough. True.
Means
So it's like both of them are equal.
in amplitude it will be equal.
Okay, sir.
In height and depth.
Yes, sir.
So wavelength means what we can say. It is distance between two successive two means successive means two only it will come now. Why two successive? Take it is distance between successive crest or throws. This distance is there, no? This distance only we are saying that lambda wavelength, and it is represented by
Sir, the upper part of a wave is crest and the bottom part of the wave is
throw.
trough, sir.
Yes, yes.
Sir, sir, I have a doubt.
1 second, right? This is what we can say about the wavelength which we can represent. Generally, wavelength we are going to measure or represent in. Okay, it is expressed in
Strips.
angstrom units. Angstrom units are nanometers or picometers. Okay, picometer means PM. Okay, generally, what is your doubt, Ranveer?
Sir, that means the crest length is equal to trough depth, sir.
Yeah.
That means the crest height and the trough depth will be same, sir.
Yes, yes.
Okay, sir.
Sir, how
Okay.
much is a picometer?
Next one. I will tell you. I'm writing that one. Generally, 1 angstrom unit equal to 10 to the power of minus 8 centimeters. Okay. Or we can say 10 to the power of minus 10 meters. When nanometer is equal to 10 to the power of minus 7 centimeters or 10 to the power of minus 9
Sir, can
meters.
you show on the previous slide?
1 second. And 1 picometer is equal to 10 to the power of minus 10 centimeters or 10 to the power of minus 12 meters. So this you need to learn the values, because in future when we are solving problems now, it will be helpful.
Sir, 1 second. So,
Okay.
Yes, sir, done.
I'll go to next slide, sir.
No, sir. Sir, wait for a minute.
Fourth or third?
Fourth, sir.
1 second. Somebody is asking no to stay.
Sir, can you once show the previous slide?
Now make it fast.
Done.
Okay.
We are sharing the PDF now.
So this is about the 10 to the power of minus 12 meters, right? So this is what we can say angstrom wavelength definition, right? Next one,
Yes, sir.
next wave characteristic is take a amplitude. Generally, we will represent with A. So amplitude means like it is height of the crest.
Sir, you wrote height spelling wrong.
Height of the crest or
Depth of the trough.
what? Depth of
Depth
the
of the trough.
depth of the trough. Okay, this is the amplitude.
Sir, it is height trough or through.
Generally, somebody will say trough. Some members are going to pronounce as trough. Okay, but actual word is trough only, right? Depth of the
Okay, sir.
now from this one, see here. So units, what we can say simply units are simply length units only, no? And simply we are going to express them units of length. Okay, what are the units length is there? No, in the same way we are going to write. Next one, next character is frequency. Frequency that we are saying that new, somewhat V type it will be there. Frequency means what we can shape and define. For example, if I'm taking a particular point, okay, from the point, in second, how many waves are going to passes through? Means what we can say simply the number of waves passes through a point per second. Okay, is called frequency, and it is represented by nu. Okay, represented by nu, right? And the units we can say is cycles per second or simply hertz. Okay, simply hertz we can say. Next one point is so amplitude frequency done.
Sir,
Uh,
sir, can you go to yes, sir. Here, that means if a crest or trough,
tell me, crest or trough?
crest or trough, how many crest or trough travels per 1 second through a point is a frequency, sir, or
Simple.
like both crest and trough, sir.
Actually, one wave means what? Crest and trough together it will be there. No, that is one wave actually. See, this is one wave. Okay.
Yes, sir.
One crest and trough together we are saying that,
Crest and trough.
that is wave. So this type of waves, how many waves it will passes through? Okay. After frequency, next parameter we are going to discuss is frequency. Next one, wave number.
Sir,
Sir,
time
cycles
period.
per second and hertz both are sensor.
Same, Nana.
Sir, time period.
Okay, sir. Thank you.
Which one, Nana?
Sir, I said cycles per second and hertz.
No, cycles per second and hertz are both are same. Cycles per second means one cycle means one wave, complete wave.
Yes, sir.
One complete wave means which will have
One
crest
crest
and trough.
and trough.
Okay. Next one, wave number. So now wave number means it is in a 1 centimeter length if I'm taking. Okay. See, we can have two definitions, that is the number of waves, the number of what we can say, wave number, no, the number of waves present in one centimeter length. If I'm taking the number of waves present in 1 centimeter length only, we are saying that wave number. Okay. Or simply we can say it is
Reciprocal.
Reciprocal of wavelength. Reciprocal of wavelength. Okay. Represented by nu bar. This we will study as nu bar. Okay. Nu bar equal to what we can say, 1 by lambda. And units are what? Centimeter inverse or meter inverse. Okay. So wave number, wavelength, and next one velocity. Velocity means what?
Speed and direction.
Velocity. That means linear speed means distance
Speed
traveled
and
by time, no?
direction, sir.
Distance traveled by time only, no?
Sir,
Speed means,
sir, why mu bar is 1 by lambda?
number of waves we are taking, no?
Yes, sir.
Number of waves, how many, simple, how we are going to discuss? It is like in a 1 centimeter length, how many waves will be there? That is only a wave number.
Yes, sir.
From
Sir,
there only we
how
are,
is wave number reciprocal to wavelength?
how to express. The value, from the value we can define, I think, Nana. When I don't know exactly. Okay. Let me
Okay,
check and I will
okay,
tell you.
sir.
See, velocity means what? It is linear distance traveled by
Sir, it is actually per centimeter, na sir, per wavelength, per centimeter. Within 1 centimeter, how many number of waves are present? So per centimeter means 1 by centimeter only. That is 1 by wavelength, wave number only.
Okay, sir.
Okay. So it is velocity means what? It is linear distance traveled by wave per second. Okay. And the units will be what we can say, simply meters per second only, no? Meters per second or centimeters per second, it will be their velocity units. So these are the general characteristics of a particular wave. So from this one, we are having one relation also, that is
Sir, why did we
Sir?
take the unit of wave number as a 1 by centimeter, sir? We can take directly as only 1 centimeter, no, sir?
actually wave number definition just now sir only told no, na? Wave number means what? The number of waves per centimeter. Per centimeter means we will write generally one. We will write 1 by centimeter only. We will write no.
Sir,
1 by
Sir,
centimeter. 1 second. 1 second. And 1 by centimeter means what? Simply centimeter inverse only, no?
Yes, sir.
What, Sasank?
Yes, sir.
Sasank or Ranveer? What? You
Shashank,
asking,
sir.
sir?
Yes, sir.
Tell me.
Sir, that means what is the symbol we use for velocity, sir?
Velocity symbol. What we can write now? V simply we can write now. Velocity simply will represent V.
Sir, but we have used like V symbol like
That is nu. That is nu. Frequency nu. We need to pronounce as nu. Nu. This is V.
okay, sir.
A relation between velocity of light wave number and wave number, not wave number, wavelength and frequency. Can be written as is equal to is given by C equal to nu lambda. Okay, where C is velocity of light, nu is frequency, and lambda is wavelength of light. Okay, so remember this. And from this one, what we can say, so from till now we came to know that each and every wave will have particular wavelength, right? Okay, similarly different types of electromagnetic radiations are there. If all the electromagnetic radiations are arranged in increasing order of their wavelength, okay, increasing order of their wavelength, are decreasing in frequencies, because wavelength and frequency are inversely proportional, no? So the obtained spectrum, we are saying that electromagnetic spectrum. Means simply what we can say.
Sir, once again, can go back.
1 second, Anna. All the radiations, all the electromagnetic radiations are differ.
Sir, once can I stop previously?
1 second, 1 second. All the differ in wavelength only. Okay. If all the wavelengths of electromagnetic radiations are arranged in increasing order of wavelength, the obtained series is called electromagnetic spectrum.
Sir, can you explain velocity once again?
Velocity means what, Nana? It is linear distance traveled by wave per second, no? Simply velocity means what? Speed with direction, no? Speed means what? Distance by time, right? What will I have written? In second, how much time it will go? Okay.
Yes, sir.
So these radiations which we are arranging in all series, no? That series we are saying that electromagnetic spectrum, or the spectrum simplet we are saying that. So in this one, the series I'm going to write here. See, first we are going to write. I will give you in a simple manner. Okay, this is actually increasing order of lambda, and as we know from this one, c by lambda equal to nu, right? That means nu and lambda what inversely proportional, no? So nu value will increases in this direction. This is nu values. Matlab frequency. Nu means what? Frequency, no? So in this one, C indicates cosmic rays.
G indicates gamma rays, sir.
G indicates gamma rays. Please quiet. X indicates X-rays. U represents ultraviolet, and V represents visible. That represents infrared. M represents microwaves. And R represents radio waves. Okay. This is the sequence of the radiations. Clear,
Sir,
Nana?
sir,
Hmm.
sir, that means these all are like we should remember, sir.
Yes, you need to remember all that. See, after which we are going to get.
Sir, IR means the EMI which we use in remotes.
Yes.
Ranveer, dude.
Right? Okay. My students, we will meet in next class.
Thank you, sir.
Bye, sir.
Thank you, sir. Bye, sir.
Bye, sir. Thank you, sir. Good night, sir.
Thank you, sir. Bye.